Okay. Do you know how to draw a Pareto?
I
Have
don't
you?
I don't think I ever have drawn a Pareto.
Oh, okay. Okay. Let's go ahead and do that. It's a good chart, uh, which probably might help. So let me just see if I have example of Pareto. No, no, sorry, I don't have it. Just give me a second while I check it out. No, it's not there. So what I can do is, oh yes, found it. So here is an example of Pareto. So what happens is I'm often late to office, right? So what I wanted to do is find out the reason of me
Mm-hmm.
being late, so that I can find out the reasons that are really impacting, and then take action on that. So I started collecting data, and I did it for about 100 days, 119 days, and wanted to find out every day what is the reason for me being late, right? So after I've collected the data, I found out 119, 5 days breakfast was not ready. 15 days I got stuck in traffic jam. 39 days clothes were not ironed. 2 days there was no petrol or less petrol or less gas. 55 days I woke up late. One day office lift was not working and my office is in 14th floor. 2 days there was no water in the bathroom. Okay, now, oh, okay, I'm sending it to you as well. So that you can use the same, and you can also draw a Pareto. So two ways we'll do that. We will what was your email? Sorry.
Sure. Scott, SCOTT dot.
Oh yes, I got it.
There, yep.
Where is the send button? Oh yeah, there it is. I've sent it to you, and let me know once you receive it.
I got it.
Okay, perfect. So there's two ways of doing it. You copy that data and paste it in Minitab. I think you'll not be able to paste it directly. You would need to copy it on an Excel, then copy it from there, and then paste it in Minitab.
Okay.
So what we have here is reason, and then the occurrence count.
Mm-hmm.
Have you pasted in Minitab?
Yep. Pareto chart.
Okay. So sorry, you go to Quality Tools and Pareto
Mm-hmm.
chart.
Okay, I got it.
Okay. So do you have a pop-up window like this?
Yep.
Defects or attribute data in?
Yep.
Okay. So the defects or attribute data that we have, it is in reason. Then the frequencies that we have, it is in occurrence count. Okay, let's click on OK. Did you get the same graph?
I did.
Okay, so let's see what is happening here. So it's a no-brainer. Waking up late was the culprit.
Mm-hmm.
Because I woke up late, 46% of the times I was late to office. Woke up late and clothes not iron. Both these causes contributed to me being late 79% of the times.
Mm-hmm.
If I just work on these two area, I would be able to take care of 79% of the time. And I think, my boss would be all right. He would not complain if I reach office, by 80% out of 119 instances. Okay, so I know I need to devise a solution so that I can wake up early, and I need to probably iron my clothes in the night before I go out to sleep, so that I have my clothes ironed in the morning.
Right.
Right. So the intention of showing you this is that right now we only have 4 or 5 factors. So we really don't need it Pareto to find out which ones are most impacting. Right.
Right.
But then once you have a big list, how would you find out? That is where Pareto can actually help you out. Okay, that is something that you can this how you would draw it in mini tab, and you can actually use Excel as well to draw the Pareto. Okay, so
Oh, okay.
you
I
want
got
to
you.
see how you do it in do it in Excel, or you okay with the mini tab?
It's just an Excel with uh two different axes. I mean, right? Pretty
Right.
straightforward. Yep.
Yes, absolutely. So what you would need to do is you would need to calculate the percentages
Yep.
and then put it as a secondary axis. So there are
Yep.
two things, you would do cumulative percentage. First arrange it in ascending or descending order, rather do it in
Mm-hmm.
descending order, then take out cumulative percent and do a secondary axis as well.
Yeah. I do those quite a bit, so I'm pretty familiar with
Oh,
that one.
okay. All right, perfect. Okay, great. And but I generally prefer this one, much more easier.
Mm-hmm. Yeah, that's really easy.
Right.
If Minitab wasn't so expensive.
Oh yes. I don't know what's the rate nowadays. When I
I think
bought it,
it's
it was
1600.
1600.
1600, I think.
Okay. I bought it. It was I think oh somewhere about 80,000 INR. So somewhere, yeah, about 1200, 1250, $1250 at that point of time.
Yeah, I can see why you don't upgrade.
Right. It's just a change in the look and feel. Everything else remains the same.
Right, it looks almost the same as the one I have, but
Absolutely. I think the only change is in the colors.
yeah.
No, but then there is some change. If you go to statistics, various tests, that one is much more advanced, right? But then I think I'm okay with not spending 1,200 bucks,
Right.
12 on this. I don't get paid enough, so I'm managing with whatever I have. So,
Yeah, exactly.
right. Okay, so coming back to Pareto, so this is how you plot it, and then we'll go to hypothesis testing. Now, what is hypothesis? A hypothesis would mean assumption. When you assume something, and then we do test hypothesis to find out whether the assumption is correct or not. So whenever you assume, either your assumption can be correct or it will not be correct. They can be there would be only two outputs. Right. So let me just show you this. Okay, so whenever you hypothesize something, there can be two output of it. Either your null would true, so null and alternate, right? So, uh, hypothesis can be categorized into two categories. One is null hypothesis and other one is alternate hypothesis. So what is null? Null means everything is status quo. There is no impact or no relation of anyone on anything. Okay. What alternate is? Alternate is exactly opposite of what null is. So if null is saying no impact, yes, alternate would say yes, there is an impact. If null is saying no relation of anyone or anything, alternate says yes, there is a relation.
Okay.
Okay. So whenever you try to do hypothesis, you would need to assume this, that this is correct, or you would want to assume that there is no relation of anyone, or there is no significant difference or no relation, and then you would check that hypothesis whether it is correct or not. Okay, and how we would do that, we will understand that, and how to interpret this with the magical value that I talked about yesterday, which is called the p value. So whenever we do any hypothesis testing, we get a p value, and basis the value that we get, we interpret whether the null hypothesis is correct or alternate hypothesis is correct, right? There's a simple rule, and generally how I remembered is, if p is high, null will fly. If p is low, null will go. So this is how I remembered. Probably if p is higher than 0.05, null hypothesis would fly. That means null hypothesis would be correct. If p is lower than 0.05, that means null will go and alternate would be true. So whenever we are checking that, if there is if there is a relationship between two factors, if we get a p value which is higher than 0.05, that means there is no relation because null is true. If p is lower than 0.05, that means null will go, alternate would be true. Alternate would mean that yes, there is the relationship between these two factors. Okay, are we good up till now?
So if it's lower than 0.05, it's alternate, right?
Yes.
Okay.
Okay, and the concept is what is p value? P value is the contribution of chance that I'm willing to accept in a statistical equation. Because remember, whenever I hypothesize in statistics, what I'm saying is I want to be 95% confidence. So 95% CI or confidence interval or confidence level that I want to take. So if I want to be 95% sure, the 5% is the contribution of chance, right? So whenever P is higher than that 5%, right? So P is high, that means I can no more be 95% confident, right? So my hypothesis fails, right? You with me?
Yep.
Okay. Similarly, if it is within that 0.5, as in less than 0.05, that means I can be 95% confidence on the result. that I'm getting. So that means, yes, there is a relationship. There is the alternate hypothesis is correct. Okay. So
Okay.
we will look at hypotheses, and I'll not go through all this. So what we have done, so if you look at this slide, this is what it is explaining, So if you look at the bell curve, so there are various tests that are there, one sided test, two-sided test. So 95% of area. So basically, this particular slide that you for T statistics or test, which is trying to say that the bell curve that we have. So 95% of area of bell curve is within this, and 5%, which is the 5% alpha, is outside this particular range. So if you divide it in the both sides, is 2.5% here, 2.5% here. Remember, yesterday we looked at we took 97.5 and we got the value of 1.96 by looking at the Z table. So why we took 97.5 is because of 2.5% area here. Okay, so I will move ahead. How do you conduct a hypothesis? Again, pretty simple process. First, you would need to state what is your hypothesis. You need to state what is null, what is alternate, and then you would collect the data, you would formulate the plan. How would you analyze it? You would analyze the sample data, and then you would interpret the result. Although it is mentioned that you would calculate test statistics and all that, you don't need to. You simply run it in Minitab. It will give you p-value. Basis that, you will be able to figure out whether it is a null or alternate is correct. And we will do some of them practically. Now, once you do that, there can be error in interpretation as well. So let us do some of the hypotheses first, and then thereafter we'll talk about these errors, which is type 1 and type 2 error. So how would you do hypothesis, which test, in what scenario you would take, is what we will find out. Just a sec. I will open a blank slide. Rather, let me open an Excel. By now, I have too many Excels open. Okay. So there's a hypothesis chart. So Six Sigma is all about data analysis. We look at the data. We don't take decision based on the gut feel. Now we know that data type can be two types. It can be continuous or it can be discrete. So we are doing a project on, and there's a project Y. So if the project Y that we have, if it is continuous, there are separate tests or different tests that you would do. And if it is discrete, there are different tests that you would do. So let's first check out if it is continuous, what do we do? So let's say project Y that we have, it is continuous, and now we have certain factors which we call X's. And let's say X is discrete. Okay, I'll give you the example as well. So the project that you did in the organization, with is average handling time. So average handling time is a continuous data, right?
Right.
Now let's find out what is the discrete data. So there were 12 locations, if I'm not wrong, you mentioned yesterday.
Yep.
So when we are trying to compare AHT of all the 12 locations with each other, so what we have 12 locations, right? We can count them. That is a discrete data. Okay. So let's assume that the data distribution is normal for project Y. Okay, and what we want to do, we want to so we have initiated the project, and first thing that we wanted to do is we want to what we want to do, we want to set a target for the project, right? So AST might be at a certain level, and we want to set a target for the project. What should be the target that you should be taking for that particular project? So how you would do that? So you would compare the project-wide data with a targeted value or a standard. So let's say the average handling time was somewhere about 20 minutes. Okay, and you're doing a project, you've initiated the project, and you're saying we would want to reduce it to 15 minutes. Is 15 minutes, is it a good enough target to be taken for the project? How would you find out? There is a test for that. So, if it is normal and you want to set a target for the project, the test that you would use, it would compare it with a targeted or a standard value. Okay, so and this test, you can only, it is a mean based test. So what it would do, it would compare the mean of sample data with the targeted value and tell you if there exists a significant difference between the sample data, between the sample mean and targeted mean. Are you with me up till now?
Yes.
Okay, so let's try and do this. See, and the name of the test is one sample t-test. Okay, let me just put it here. Okay, so there is a one sample t-test. What we want to do, we want to set a target for the project. So what the test will do, it will compare with a targeted value. It's a mean based test, and it will compare the mean of sample data with the targeted value. Okay, and two piece of information that it will have a sample mean and a targeted mean. Okay, so okay, now that was when you're comparing a sample with a targeted value. Now there is something known as two sample t-test. What this test will do, it will compare two samples with each other. Some reason my laptop is working very slow. Okay. It will compare two samples with each other.
Okay.
And tell us if there exists a significant difference between mean of both samples. Okay, so are we good with two sample t-test? So what we'll do, we'll compare two samples with each other. So we want to, suppose we have two locations, and we want to see, is there a difference in the performance of two locations in terms of AST? So we would compare the AST of both the location. It's again a mean based test. It will compare mean of location 1 with the mean of location B and tell us if there exists a significant difference or not. Okay, so if there is a significant difference, we know that there's something wrong, in the location. So we need to look at the particular location to find out, what are they doing wrong or what are they doing good. Okay, so since you got the data, can you open the first file, which is one sample t-test?
Okay.
Let me also open it. No, I'm not able to open that one. 1 second. Let me try closing a few files. Just a second, Scott. I'm struggling with my Excel here. Still unable to open this one sample t-test data. Okay, so why don't you, anyways, why don't you open the data
Okay.
of one sample t-test, paste the data in Minitab.
Got it on Minitab.
Okay, now let me just take any data here.
It looks like the same data.
Oh, is it?
Yeah, but it's just got a C column. A and B is the same data.
Oh, and with the same data, perfect.
Yep.